Number 25, which expression is equivalent to y plus 12 over x minus 8 plus y times x minus 8 over x squared y minus 8xy? With these kind of problems, when they say which expression is equivalent, I always recommend looking at my answers first. Kind of know where I'm going. Sometimes you will see things being left in binomial form. Like there might be, see up here, we have a binomial y times x minus 8. And sometimes when you see that and you go down and you look at the answers, you'll see an x minus 8 somewhere still lingering in there. In which case you know, oh, okay, I don't need to multiply. I just need to leave that alone and do something else. That is not the case here. Every answer has things that are combined, distributed. There's no parentheses in sight. So we're going to get rid of those parentheses very quickly. Also, all four of these are a combined single fraction. So I know I'm going to have to figure out a way to combine these two by creating a common denominator between the two of them. The denominators, those bottom numbers, those bottom terms, those bottom polynomials, they have to be the same. All right, so on the left, I have my y plus 12 over x minus 8. And on the right, I have y times x minus 8. That 8 went crazy as my stylus jumped. There we go. Over x squared y minus 8xy. So I have two things I need to do. I need to simplify that, or distribute that, I should say. And then I need to make these two match. Okay, so how do I get from x minus 8 over to x squared y minus 8xy? Is there something I can just multiply x minus 8 by to get to that? We're going to look and we're going to see. It's one of those two things. You look at the one that's more complicated and you say, okay, can I take this simpler one and multiply it by something to get to the more complicated one? If that's possible, that's great. Another thing that may happen is there has to be one that kind of is in between, shall we say, where I have to multiply this by something and also multiply this by something to get to a common denominator. That's also possible. So I'm going to look at, because I see an x there and I see a minus 8 there, I'm like, maybe. If I were to say, is this x minus 8 times something? Could I pull something out to leave x minus 8 behind? Well, x squared times y, what would I multiply it by to get to x? I would need 1x. X times x is x squared, going backwards. And I would need a y, because y times 1, y times nothing is y. So x times xy would get me to x squared y. All right, does negative 8 times xy get me to negative 8xy? It does. So okay, xy it is. I can pull xy out of this x squared y minus 8xy, leaves x minus 8 behind. So that means that I can just take that xy, multiply it over here, and then I'll have my common denominator. But is it just xy? Well, I can't change this. I can't change this fraction in any way, so I can't just multiply the bottom by xy. I also have to multiply the top by xy, because then I'm multiplying by 1. A number over itself, except for 0, is 1. So xy over xy is 1. I can multiply this fraction by xy over xy, and I'm not changing it. All right, so let's do that. First, xy times y plus 12. Again, we're setting it up. It's like parentheses, but there's no parentheses in the final answers, so we need to distribute this. First, xy times y, xy squared, y's get together. Xy times positive 12, 12xy. And on the bottom, we already know this is going to get us the same as the other side, x squared y minus 8xy. All right, I'm going to write that again over here, x squared y minus 8xy. Now on the top, I want to distribute. Y times x is yx or xy. We put those x's first. y times negative 8 is negative 8y. Now that I have common denominators, I can combine everything on top. This is behaving just like those fractions you learned so long ago in elementary school. Things like 1/3 plus 1/3. How many thirds do I have? I have 2 thirds. So you add the numbers on top, the bottom stays the same, because that's what it's saying. It's not saying we add the numbers on top, we add them on the bottom. No, it's saying I have 1/3. I have 1/3 of a thing, and I have another third of a thing. So now I have 2/3 of the thing. So in this case, it's like I have xy squared plus 12xy of x squared y minus 8xy's. And I want to add xy minus 8y of x squared y minus 8xy. How many x squared y minus 8xy's do I have? That kind of thing. So we combine all those terms on top. We see if there's any common terms, any like terms that we can add. So we have xy squared plus 12xy plus xy minus 8y all over x squared y minus 8xy. One thing to be mindful of, this is a plus, which makes it nice and simple for us. If this were a minus, always remember it applies to everything, so change the signs on everything. Just a little tip there, because they like to throw those in. Okay, there's only one xy squared, so it doesn't change, it just stays xy squared. Then 12xy and 1xy. How many xy's do I have? I have 13 xy's, and then that minus 8y, it just stays the same. You have that x squared y minus 8xy on the bottom. Now, and so xy squared plus 13xy minus 8y over x squared y minus 8xy, and that is C. Now I'm going to zoom in on those answers. If you look at this, you see how this is the only one that has x squared y minus 8xy. So it is reasonable, once you get to the point where you know that that's the common denominator is going to be x squared y minus 8xy. That is a reasonable assumption that this is the answer at that point, given our other answers. Why do I say given the other answers? Because it is possible, we already know that xy times x minus 8, you can pull that xy out. There are problems where after you combine them, that you might realize, oh, I can pull an xy out of the top and an xy out of the bottom, and then they cancel out so I can simplify it. So if you saw any other answers here that were simpler, that looked like they had pulled that xy out and it was just an x minus 8, they would be in the running, and you'd need to take a look at them too, and you'd need to just keep going on with the problem. But yeah, sometimes with those multiple choice answers, you go, wait a minute, is it just C because it's got that denominator? Yeah, in this case, it really is. None of the others are possible. They're really kind of honing in on your ability to find that common denominator and what you do with it. Some of these are going to be like they multiplied those together. Yeah, that's what's going on with some of these other, the other answers. However, I don't like to just say, you know, I don't want to just stop halfway through this problem, because you're like, wait a minute, Alyssa, you can just look over there and you can see it. You know, you don't have to go through the thing of adding them together and combining the like terms. Why did you do that? I did that because they're not always nice. They don't always give you this nice little one where it's the only one that would work. So you need to know how to be able to keep going through the problem and complete it. So even when you get one with a little more, some more reasonable options, that you know how to find the complete answer. But yep, in this case, it is C.
Hey guys, this video was helpful or useful in any way, please feel free to let the algorithm know about it. Like, share, comment, subscribe, even buy me a coffee if you're so inclined. Links for that down below as well. Thank you so much for stopping by. I hope you have a great day. See you later. Bye.